Okay, so introduction to gate logic. Let's take a look at this one here first. 7408. This one here. And you can see 7408, that's an AND gate. And if we look at the truth table over here for an AND gate, our possibilities for our inputs. This is a 4-input AND gate that I'm showing you here, which is exactly what you have for your kits. And your possibilities for inputs are a 0 on A and a 0 on B, a 0 on A and a 1 on B, a 1 on A and a 0 on B, and a 1 on A and a 1 on B. And your possibilities for outputs on that is, well, an AND gate says, well, if I have a low and I have a low on B, I'm going to have a low on my output, and I'm calling my output Y. And over here it says if I have a low on A and I have a low high on B, I'm going to end up having a low. And same thing here, a low on A, sorry, a high on A and a low on B is going to give me a low output, and a high on A and a high on B is going to give me a high output. So it's going to output that signal. So an AND gate. So the only way you're going to get an output on an AND gate for a high is if you have a high on both the A and the B. Now let's take a look at the NAND. That's why I left this little column here. If we look at the NAND gate, a NAND is this one here. This is the NAND here. That's the 7400, and it looks the same, except it's got this little dot that's right in front of it there. So the NAND gate is actually the opposite of the AND gate, and you can think of the NAND gate as not AND because it's like having a not at the end of your output. So it just changes the output from a whatever it is to the opposite. So if we take a look at this here, we've got a 0 and a 0 on a NAND gate would give me a high, and a 0 and a 1 here would give me a 1, and a 1 and a 0 would give me a 1, and a 1 and a 1 would give me a 0. So it's the exact opposite of the AND gate. Now let's take a look at one of these other ones here. Let's take a look at the OR gate. So the OR gate is the 7432. 7432 right here. And you can tell that it looks a little different. It's like curved at the back and it kind of comes down. You'll see some drawn like this where it comes more to a point like that, but it doesn't have that dot in the front, so we know it's an OR. And an OR gate, same input possibilities, 0 and 0, 0 and 1, 1 and 0, 1 and 1. And an OR gate says for its output, in order for this to output a high, one or the other has to be a high. So 0 on 0 is going to give me a 0 on a 1 is going to give me a 1 and a 0 is going to give me a 1, and a 1 and a 1 is going to give me a 1. And if we look at the NOR gate, which is the opposite, NOR, which is the opposite of the OR gate, and it looks like this, where it's got this little dot on the front of it. And that would be the 7402. Is the NOR. So we're looking at this one here, 7402, and the NOR is the opposite. It's like having your OR gate like this and then outputting it to an inverter or a NOT gate which looks like that. So it's not or, and it's just going to invert whatever those numbers are. So 0 and 0 is going to give me a 1. A 0 and 1 is going to give me a 0. A 1 and 0 is going to give me a 0, and a 1 and 1 is going to give me 0. So it's exact opposite of the or.